quotient function derivative, example 2, quotient rule. So quotient means divide. Now we've got a fraction function here. This is u and this is v. And now we need to find the y, the x, which is also can be written as y dot or y dash or even f dash x. Or you might see it as change in y over change in x, or rate of change of y with respect to x. So those are the ways of expressing differentiation. Or they might say tan of an angle theta, because they all mean differentiation really. Y equals 5e to the power of x divided by cos of x. So we say let u equals 5e to the power of x, and therefore the u, the x, is going to be 5e to the power of x. Same thing. Because if you differentiate e to x, you just get e to x. And there's a 5 here as a constant, you just multiply by the 5. And then we say let v equals cos of x. So we say let v equals cos of x. The v, the x, will be minus sine of x. Now we're going to apply this rule here. So we want the y, the x, will be v, the u, the x, minus u, the v, the x, over v squared. And so we can place those values here into there. So the y, the x, will be v is cos of x, and the u, the x, is 5ex. So I will put that here, 5e to the power of x, minus u, which is 5e to the power of x, and the v, the x, is minus sine x. So because that's minus here, it will make this cos plus, because minus times minus is plus, of x, divided by v squared. So v is cos squared x. Just to remind you that if we're writing cos x squared, it's also written as cos squared x. Same thing. Now that we've got that, so now we need to simplify. You can see 5e to the power of x is common factor here. So we can now have the y, the x. So we now have the y dx equals 5e to the power of x is a common factor. So go 5e to the power of x, open bracket, cos of x plus sine of x over cos squared of x. And that will be the solution that we're looking for. Y equals 5e to the power of x divided by cos of x is, the y dx is 5e to the power of x, open bracket, cos x plus sine x, close bracket, divided by cos squared x.